Let's solve a problem using the intermediate value theorem. We need to prove that there is at least one real solution to the equation x cubed minus x minus 1 equals 0 within the interval from 1 to 2. Let's solve this step by step. First, let's define our function f of x equals x cubed minus x minus 1. Since this is a polynomial function, we know it's continuous for all real numbers. Now, let's evaluate our function at x equals 1. When we plug in 1, we get f of 1 equals 1 cubed minus 1 minus 1, which equals negative 1. Next, let's evaluate our function at x equals 2. When we plug in 2, we get f of 2 equals 2 cubed minus 2 minus 1, which equals 8 minus 2 minus 1, which equals 5. Let's visualize this function on a graph to better understand what's happening. Now, let's apply the intermediate value theorem. We can see that f of 1 is negative 1, and f of 2 is positive 5. Since our function is continuous and changes from negative to positive by the intermediate value theorem, there must be some value c between 1 and 2 where f of c equals 0. Therefore, we have proven that there exists at least one solution to the equation x cubed minus x minus 1 equals 0 in the interval from 1 to 2. This solution is approximately equal to 1.839. The key to this proof was using the intermediate value theorem, which states that if a continuous function takes on two different values, it must take on all values in between. This is a powerful tool for proving the existence of solutions to equations.